Hello ladies and gentlemen, and welcome to today's training, Gaining Real-Time Insights from the Internet of Things and Using Azure Stream Analytics. My name is Jens and I will be in the meeting for the first 15 minutes, so if you have any issues, you can contact me by typing a message in the instant messenger window. I am logged into this meeting as meeting operator. This is a one-way audio session. During this session you have the ability to ask questions using the instant messenger window. You can also send us an email to vrexsub@microsoft.com. Please note that this session is being recorded. Thank you in advance. And now I would like to hand over to your today's instructor, Anindita and Devika. Have fun.
Thanks, Jens. Welcome everyone. So this is today's webinar. We are going to talk about real-time streaming analytics with Internet of Things using Azure Stream Analytics. So before we are going to start the presentation for today, I would like to take a short poll just to check where you are right now with Internet of Things, with Azure and real-time data streaming. And I have also today with me my co-presenter Devika. So she would be taking up your questions. So during the entire webinar, if you have any kind of questions, so just type in the chat window and Devika would be letting me know so that I could answer the questions. So Devika, you can present yourself.
Thanks, Anindita. Good morning, all of you, and thanks for joining in. So today we are going to talk about, Anindita is going to present on gaining real-time insights from the IoT using Stream Analytics. I really hope you enjoy the session, and please let us know if you have any issues in the audio in between, or if you want, if you have any questions, you can type in the IM chat window. So we both are working as Azure partner technical consultants in Azure Platform as a Service as well as Azure Data. Thank you, Anindita. You can continue. Yeah.
All right. Thanks, Devika. So I am quickly sharing my screen to start the presentation first. All right, so I hope everyone can see my screen. So folks, today we'll be talking, as I mentioned, that we will be talking more about real-time data streaming. So in my last sessions of last month, I have talked about the data, that's big data problems in batch processing environment. So I have talked about the components like Azure HD Insight and various components of Hadoop, how big data platform works in Hadoop with Microsoft platform, Microsoft data platforms and analytics platform. So today, actually this month, my two webinars would be based on real-time data streaming. So from the static environment of big data processing, we will be talking today, and also in my upcoming webinar, we will be talking about real-time data streaming analytics. So today's sessions will be focused most with the IoT streaming analytics using Azure Stream Analytics, Azure Service Bus Event Hubs, and end-to-end data visualizations with Power BI, Azure SQL Database, Azure Blob Storage, etc. And in my upcoming webinar, which is on next week, that is on 17th of August 2016, I would be presenting another webinar that would be covering end-to-end on choosing the right platform on whenever you are thinking about to have a project on data streaming, real-time data streaming. So which kind of technologies that's to choose. So because you have today a lot of technical components, a lot of technical options. So either go with Azure Stream Analytics or go with HD Insight with Big Data Hadoop platform, or to go ahead with Microsoft SQL Server Stream Insight. So we'll be talking on that. So that would be a more in-depth session. Level of the session for today would be just in between 200 to 300. We will be starting from basics, but towards the end we would be just going towards advanced. But my next webinar would be advanced session. It would be the level would be 250 to 300 level, and it would be covering end-to-end real-time data streaming analytics platform. So introductions we have already given. I am Anindita and I have today with me Devika. We both are partner technical consultant of Azure Data Platform. So this is our today's agenda. So we would be talking about what is data in motion. So we have already mentioned about how to tackle a big data challenge, how to work with a big data problem. We will be starting now with shifting to a streaming data solutions, how the approach has came to real-time analytics. So what is real-time analytics? What was the traditional analytics approach and what is the current streaming data analytics approach? What are the complement for the existing analytics with streaming data problem? And also, we would be sharing some small customer stories because there are a lot of customer use case studies you can see in right now in Microsoft Azure Analytics website. So we'll be talking few of them, the real-time use cases of them. And then end-to-end, we'll be covering about Azure Stream Analytics, what is the setup, and we'll be, of course, showing a lot of demos, IoT solutions, data is coming from sensors, real-time to live dashboards in Power BI. We will be talking about a lot of fun demos, where we'll be showing some the age analytics, like howol.net site. Then I will be also talking about in more technical, in-depth, what are the different components of Azure Stream Analytics, how to provision an Azure Stream Analytics jobs, how to pass the data from on-prem to Azure Service Bus Event Hub for the event processing, then to Azure Stream Analytics, and then finally to visualization. So I'll be also showing some sorts of solution architecture diagram for an end-to-end POC. And of course, we will be talking about some upcoming IoT perspective that Microsoft is having, Azure IoT Suite, some customer evidence videos. That's all would be there in this today's session. So I hope that it will be enjoying for you. And let's get started. So what is the problem that today we all hear about whenever we have been working in data platform or in data cloud platform, big data cloud platform? So traditionally, if I talk about what was the real-time analytics people used to understand, even just a few years, 5 to 10 years back. So the majority of business intelligence and analytics solutions that have been designed around the concept of batch operations that move the data between different persistence data store. So we have been actually constrained to the era of relational databases or analytics cubes. So when users would then have to issue the query against the data at rest to support the various scenarios such as ad hoc analysis, dashboards, or scorecards like that. But with the time, the challenges have become more and more complex. So there was a need to enable and shift to a streaming data solution. So in sorts of enabling a real-time analytics-based solution on streaming data, it provides a solution to a number of challenges of real-time data at scale. So the model for the implementation that represents a significant shift by moving from point queries against the stationary data or to a standing temporal query to that consumes the moving data. So streaming data solutions are right now, it's an introduction to the data marketplace. So you can just heard of many of this particular terminologies like detection anomalies, fraud detection, improving operational efficiency, or use-based pricing, or predictive analytics, or predictive modeling. So these are the very common terms nowadays, those who work in big data, or those who are thinking to shift to work in big data, or those who are planning to have an enterprise application in big data. So there is actually today is a complement that is existing with existing analytics along with streaming analytics. So what is data in motion? The first comes a question. So we all know that data, it rests over the relational database. We have some sorts of RDBMS environment. There we store the data in forms of schemas, tables, views, stored procedures, and all. So, and also we can do some sorts of batch processing, like the technical component, like in big data problems, if we have like a tool called Hadoop. So, and for Azure in Hadoop, we have a tool like HD Insight, and under HD Insight, we have various components like for batch processing, for streaming and all. But that's all about like data which are being staying. It is being stale, or the data is being at rest. But what is a solution that we can provide when the data is coming in real time and it is continuously in motion? For example, I can give an example of a toll gate. In a highway, everybody see that each and every time there is thousands of cars passing by of the toll highway. And so there is a very difficult in such cases in a toll highway to make a calculation for a certain time period that how many numbers of cars have been passed away like towards up or down from the specific time interval. For example, from morning 9 a.m. to afternoon 12 noon. In these 3 hours, how many cars have been passed to? So in such cases, that's a real-time scenario of data in motion. So there we need something, a challenge of make a calculation, aggregation of real-time streaming data. So this is a concept of the data in motions, like when we just want to enabling the analysis of moving data. That is just an approach of considered for a number of existing business information challenges. It is not intended to be a replacement for one or more traditional batch-oriented analytics architecture. There remain many scenarios where streaming analytics doesn't fulfill for solution requirements. But additionally, today we can offer the stream analytics not only just for real-time data in motion, but also we can apply it for massive parallel data warehousing solutions that can now natively scale out through the architecture, such as we know MPPs. They can provide the near linear scale across the database cluster through the shared nothing hardware design. We can apply it through the traditional ETL approach to an ELT solution, extract, load, and transform solutions that I have discussed in my HD Insight webinar. So that all the data that where it can be stored and analyzed on demand. So Microsoft currently provides 3 event stream processing that customers can deploy for their solution. So one of them is of course using Azure Service Bus Events with Azure Stream Analytics. Second one, we have Azure HD Insight Storm components, Storm as well as Spark. And third one is Microsoft SQL Server Stream Insight. So we'll be talking about the rest of the 2 in my upcoming webinar. So this is this current deck. As you can see, there is a customer evidence, a case study has been presented. Like there was one of our major customer partner, Fujitsu, who just have worked with in collaboration to transform their major manufacturing processes through IoT innovation. So they have not only they just gained the high quality manufacturing based on real-time insights from the data, like multiple million sensor data that has been sending data in real time through Azure Service Bus Event Hubs to Stream Analytics and as an input, and then pushing into and real time they have been processed through analytics like machine learning through sensor data analytics, and then finally the live dashboards and alerts they will be able to see in their Windows 10 laptops, so through Microsoft Power BI. So there is a video is being there, the case study is being there in Microsoft Portal, and once I would be presenting with you the resources, you could be able to see from my deck as well. So it's a very good customers evidences, and there are many customer evidences and case studies are there that who have already migrated and collaborated in IoT platforms with in manufacturing, in automation processes, worked with Microsoft Data Analytics platform. So what are today customers they want to do? So customers, they want to apply Internet of Things and real-time data streaming in this following scenarios. It's not limited to this particular scenarios only, because not only in real-time, just 8 scenarios are there where we can apply Internet of Things and real-time data streaming. But these are one of the 8 major areas where this particular scenarios have been visible. Like we can, most of all, we are mainly concerned about our credit card fraud detection, so we can apply it to the real-time fraud detection scenarios. In connected car, even I will be showing a demo today on connected car scenarios, like real-time in 4 or 5 different cities. The cars, the majority of the cars have been traveling through the roads, highways, and the data has been pushed into in real-time. They have been pushing, and it is being into Azure Service Bus Event Hub, and from Event Hub, the data has been pushed into Azure Stream Analytics as an input, and the data has been processed through say SQL, Azure Stream Analytics SQL query language, and then finally pushed into Azure Power BI as a live dashboard. So connected car is one of the well-maintained case study, and it is also integrated with Cortana Intelligence Gallery. Clickstream analytics, of course, it is a very well-known big data problem, and so people wants to know for real-time e-commerce business, like what was the business value, how many people are doing the online shopping, how many people are just spending time but not doing the shopping, how many people are adding the items into the cart. So what are the top 5 popular products? What are the top less popular products? So these are the scenarios of real-time clickstreaming. Then another case is like in financial industry, they would like to go ahead with financial portfolio alerting system or smart grid system or financial sales tracking. So these are one of the major areas where Azure Stream Analytics and there's all sorts of data analytics PaaS offering provides the event stream processing. And we would be coming to see as I progress more and more slides today. So you would be able to see that how there's some sorts of differences that will influence the decisions of which platform is best suited for the project. So you could be able to compare on the various areas, like you can compare first of all in terms of language, like how Stream Analytics supports a SQL query language, has an easy interface and similarity to a SQL server T-SQL. In terms of deployment model, you could be able to see like Stream Analytics has built-in multi-tenancy support. Then maintenance cases like Stream Analytics is a fully managed services, no patching, no administration, just a pure platform as a services offering, just plug and play, use it, push it the data, process it, and output as a data visualization. You can see it to the dashboard in real time. And there are a lot of interoperabilities today Azure Stream Analytics have been providing today as a first-party click and configure support, like with Azure Event Hub, Azure Blob Storage, Azure SQL Database, and it can easily integrate with Azure HD Insight components as well. Or also, if you want to think about the third-party data, NoSQL databases like Apache Cassandra, HDFS, or SQL Data Warehouse, so all the components you can interoperate. So these are the scenarios today with the data analytics platform, in real-time data analytics platform, and especially you can see in Internet of Things environment, like ingest data, where we can think of like archiving data, then analyze the data, for example, in case of telemetry or traditional log processing environment, or then moving the data from ingest to analytics and then finally into transformation. So we all know today we are in the age of digital transformation, where there is a need to transform the data to make the insights of the data. Because everywhere we can see there is a big data problem. Everybody says, yes, we have a lot of data, but how to gain the knowledge, how to make the data valuable, and how to get actual insights of the data and discard the unuseful data. So that is something like it's a way that we can do with Internet of Things. So we can connect multiple devices. Everybody knows that today, even with next 5 years, we could be able to connect even more than 5 million devices with Internet, and we can get insights from the data that's being sending by those devices. So this is the digital actions that could be taken up with a proper value proposition with real-time data in the Azure platform. So by implementing those kind of automated data systems that can monitor and act on the repetitive known business processes, or they can potentially detect the outlier events that as they occur. So organizations today, they can redeploy the human resources away from the lower value repetitive task to move their responsibility to the high impact analytical tasks such as researching new target markets or process optimization. So coming ahead with Azure Stream Analytics. So Azure Stream Analytics, as we know, as it's being said, like it's a fully managed real-time analytics system. So it has a capability, Stream Analytics has a capability to gain over the millions of events per second. So you can process over the events through Azure Stream Analytics up to 1 gigs per second, and it is helpful to easy process the continuous stream of data. So just a few minutes back, I talked about the toll highway, where for suppose in 3 hours, the thousands of cars have been passing by. Now I want to analyze that how many cars have been passed by in in this 3 hours, towards in up or towards in down, or how many a specific model car have been passed, what was the total speed, what was the car fuel level, what was the efficiency level, engine efficiency level. So this types of analytics, if I want to do with the cars that is being passing by the toll highway, so in that cases, I don't have to go ahead with traditional batch processing environment like big data, Hadoop framework with Pig, Hive, and HDFS, or any sorts of SQL Server environment. Of course, I have to take the help of something like a real-time data analytics component with having the facility to get the data in real time, like sensor data or vehicle telemetry data. I can push it and I can process it. So it is not uncommon for streaming data solutions to consume data from globally distributed systems. Of course, not only just like car or sensors or Kinect or Xbox. So we can connect data with Windows Phone or your Surface, mobile applications or web servers that have been logically deployed to reduce the request latency. So deploying the cloud-based services that can help customers to effectively deploy processing capability where data has been generated, thereby just reducing the cost of regional data center deployment, such as bandwidth or fixed capex infrastructure cost, while it is also benefit from the elastic consumption pricing and native scale-out capabilities that support unanticipated growth or decline in consumption. So it's as Stream Analytics is a fully managed services. Of course, it has there is no administration required, no hardware acquisition or maintenance, and you can easily expand your business globally with the help of Stream Analytics. We can correlate with the different kinds of streams. So Azure Stream Analytics, even when I'll be showing the demo, you could be able to see there are two kinds of data stream environment works with Stream Analytics as an input. So one type of data is a data stream, another type of data is a data reference data. So both of the data streams have been different in terms of input processed through Stream Analytics. But yes, you can correlate the different kinds of stream, whether data is coming from Service Bus Event Hub or whether data is coming from an IoT Hub. Azure IoT Hub just recently came up last year. It has been published. It was a preview till now, or it is coming from a static storage like in Azure Blob Storage. So, and also you can find some specific patterns, or even there is no pertinent pattern, but you can process those data in real time through Stream Analytics. So, of course, in mission critical approach, Azure Stream Analytics can scale up. So it provides a guaranteed event delivery for process data continuously. It has a auto-scaling fast recovery. We can scale up the streaming jobs over there. We can configure the jobs to have the maximum amount of scale based on the data, input data that has been processed. For example, we have been collecting data and processing the Twitter sentiments in real time for some specific hashtag of Twitter, for example, in Rio Olympics 2016. And such kind of Twitter sentiments we want to get where the data has been continuously processing all over the time in 24/7. So in such cases, I will be also showing some a POC on that. So Olympics sentiments Twitter analytics with Azure Stream Analytics, Azure ML, and Power BI. So in such kind of a scenario, you can easily scale up those of the particular streaming jobs, because where suppose in that cases the data would be coming per second, maybe for thousands data that would be coming up, or per minute there would be just millions of events that needs to be processed. So in such a cases, you can scale up. There is a scaling unit in Azure Stream Analytics which you can scale up and you can process the data according to the particular requirement. And you can also spin any numbers of resources on demand. You can scale from small to large as when required. So as I said, like when for a particular timing, I know that my millions of data that would be processed in per second, for example, a real-time live event that whenever it's happening, or after a few months when it has been already done. But then at that time also, whenever there is a tweet serving coming up from social media, or the data is still need to be processed, but I can scale down, or I can manage the scaling unit as based on the requirement, because it's completely distributed and scale out architecture pattern. So, of course, it follows a rapid development scenario. So, rapid development with the help of Azure Stream Analytics SQL query language. So, I will be talking in depth about the query language, but how it is helpful in case of RDDs for rapid deployment and development. So, it helps to decrease the bar of developer required for streaming. So to work with Azure Stream Analytics, we don't need to be a separate skilled developer today. Those are the developers who have minimum knowledge about SQL. They can work with Azure Stream Analytics because it's just like they have to integrate the input with the Azure Event Hub or blob storage or IoT Hub. Then they have to write some sort of SQL query language through Stream Analytics. And finally, once the SQL query language has been connected with the input, output, and the proper processing with some sorts of DML, DDL languages specific and some sorts of specific query have been given like average, minimum, maximum. Our query has been done, and I will be also showing you in the demo as well. And finally, I can choose out the proper output path where I can visualize my data, final process data. So it's a pure rapid development approach. So no separate language, no separate skill set, low learning curve, just less maintenance of the code has been required. Once you made a stream analytics job, it can work, it can run for a year while. And development, debugging, and pure monitoring experiences you'll be able to see. There would be a dashboard, there would be a separate monitor where you can visualize your data streaming, input, output events, failed over events over an hour, over last 5 hours, or over the day, over the week. And you can easily integrate with other Azure component, platform as a service components. It has been easy to build with IoT scenarios. So today, with any source of IoT devices you have been working so far, whether you have been working with Raspberry Pi, with Windows sensors, or whether you have been working with weather streaming, weather sensors to take the real-time weather data analysis. So any kind of devices or Windows phones, even if you're working so far. So you can take up the events from those devices and push out to Azure Service Bus Event Hub through or blob storage, push it to Azure Stream Analytics, and publish into as a necessary output for data visualization. So in the beginning, I would like to show first a demo. So my first demo that would be based on vehicle telemetry analysis. So you can see basically the dashboard of vehicle telemetry analysis. So this is just as I mentioned, it's the scenario of connected car. So how the devices telemetry or how the connected cars has been growing at exponential rate. And you can see that my dashboard, this Power BI dashboard is, it's a real-time dashboard. So it's been changing. Nothing is static. I don't have to schedule refresh or refresh manually anything because my data has been running in real time, and the dashboard is being also updating and refreshing in real time. So it is a case of connected car. Some of the connected devices today we know, such as security badge readers or IoT connected cars, they are quite mature today in their adoptions. Vehicles or smart buildings as well, they are still very much in their infancy. So if we enable the real-time analytics for those connected vehicle, or manufacturers just enable the new levels of visibility into those running performance of the given vehicle. So rather than waiting for download the telemetry data and then schedule the vehicle services, etc. So large commercial industrial buildings, they have the support to depend on the number of systems to support for the day-to-day operations. But what happens when you want to know specifically in a long highway, whatever the engine efficiency of my car, or whatever the fuel efficiency of my cars, or for different cities, if they want to travel for a long drive from one source to the destination. So what would be the approximate length and the time required to journey, and what would be in the high level, what would be the temperature, what could be the approx engine oil that needs to be consumed. And for a smart city perspective, what would be the average fuel consumed in different cities? What would be the pollution level? What would be the noise level? What would be the CO2 indexes and all? So vehicle telemetry analysis, it's one way to solve those particular challenges. And you could be able to see that this particular solution is also well integrated today with Cortana Intelligence Gallery and Cortana Analytics Suite. So as you can see the dashboard, so along with, I would like to show that how the demo has been built so far. So as you can see, in the top, we have some sorts of God charts is there. that represents the total speed of the car. That's 12.66 million. Total fuel consumes is still now it's 4.25 million. Tire pressure, engine oil, odometer, engine temperatures, and total numbers of car models. So this particular analysis has been done in 4 different cities like Bellevue, Seattle, Redmond, and Sammamish. Apart from that, you can process the data from connected devices in any of the cities, and you can analyze those particular details. Once the data that needs to be processed through the data has been generated in real time from those cars, it needs to be processed. So for the processing purpose, we need a proper data stream. So what I'm doing to show that, I am moving to my Azure portal. So as you can see, I'm right now in my Azure or Classic portal, and here I have my vehicle telemetry job, which I have created as a stream analytics job. To create a stream analytics job is pretty easier. Once you are in the Azure portal, whether Classic or in the new itself, you can go to New, and under Data Services, you can select Stream Analytics, and you can select Quick Create, and you can give first your job name. Stream Analytics Demo. You can select a specific region. So right now, Stream Analytics jobs, it's available almost every region, along with Australia data centers as well. So we can select even, for example, in India, it is available only in Central India. Or if you can select also Southeast Asia. And once you select, you need to select a particular regional monitoring storage account. So if you don't have any particular regional storage account, so you can also create on the same. So you need to give the storage account name. And once you have given the storage account name, just click on the right icon to create the Stream Analytics job. So in order to build the Stream Analytics job for vehicle telemetry analysis, so I have done the same thing. I have created a Stream Analytics job. As you can see, my job is in running state. And first, let me show the dashboard, how it looks like. So this is the dashboard, as you can see. So once you create the Stream Analytics job, you have basically 3 tasks that needs to be done. First, you need to add a specific input. So you need to go to the Inputs tab, and you need to add the inputs. So since my job is in running state, so what I'm doing, I am quickly stopping the job, and let me show you how to add an input to your Stream Analytics job. It will take 1 or 2 minutes to stop the job. So the data, that's the car events data that's being generating in real time. So I have specifically a lab environment is being created where all those data are generated in real time. So as you can see, let me stop my solution. And so this is in the Visual Studio solution. You can see I have a specific app called Car Event Generator. So in the Car Event Generator in this app, what I have done, I have just being added a few parameters for Service Bus Event Hub connection string. So where I could be able to add those specific connection details for the Service Bus Event Hub. So before you can start, if you think that you need to process the data through Stream Analytics through Service Bus Event Hub, you need to also create a Service Bus Event Hub. So Service Bus Event Hub creation is also easier. You need to go to your Azure portal. For example, as you can see in my Azure Classic portal, if you go to Service Bus and if you click on New, so under Service Bus, you could be able to see all the Service Bus components like Queue, Topic, Relay, Notification Hub, and Event Hub. So you could just click on Event Hub and you can click on Custom Create and you can start creating an Event Hub, which would be processing the data from your connected devices to Azure Stream Analytics. Event Hub demo, and then you can select a specific region. Region again, you can select your nearest one. and you can select a namespace. So for existing one else you can choose, or you can create a new one as well. If you are working for the first time, you can create a new namespace and you can give a namespace name. And once it has been done, you can add a partition count. So partition count basically enables you to set the numbers of partition, because each and every data that is being coming out in real time and pushing into Event Hub, they have been partitioned properly. So without partitioning and without a proper patterns, the data storage, the data would not be processed through Stream Analytics. So by default, you can give a partition count 7, 16, or maximum 32. So I'm giving it 16. And message retention is TTL level, the time to leave, that how many days the particular message would be leaving in the particular Event Hub. So the messages would be kept. So it can be good to give it 7 days. And once it has been configured, you can click on the complete icon so that the particular Event Hub can be created. So this is the process to create an Event Hub in Azure Service Bus before you can start working with Stream Analytics. Now, as I was showing in my lab environment that how the data has been generating from the vehicle telemetry. So here I have the custom functions that I have written for a specific car. For example, I want to get the parameters like the temperatures, the city, the vehicle index number, outside temperature, speed, fuel, engine oil, tire pressure, odometer, parking, brake status, brake oil, transmission gear status, timestamps, etc. So these parameters I have been passing through JSON convert and serializing it and pushing into Event Hub. So once I have started to run this particular messages, so process this particular messages by starting this particular console application, what it will do, it will generate the random car event generator data and it would start to push it to Azure Event Hub. So Azure Event Hub details I have already given in my app config file. So this is my app config file where I have already provided the details about my service bus Event Hub endpoint. So connected car demo.servicebus.windows.net. So this is the details. And this particular connection string, the service bus Event Hub connection string, you could be able to get from the portal itself once you create the service bus Event Hub namespace. So for example, here this Event Hub I just created. If you go to Event Hub now and open this particular Event Hub, and you can select the connection information. And once you select the connection information, so you can click on view connection string or connection information from the bottom. You need to select a shared access policy. So for example, just give a name and just give a permission, like what your Event Hub can do. Either it can send the messages, or it can only listen to the incoming messages, or it can manage both of them, bidirectional communication. So I've given both of them, 3 of them actually, and clicking on save. Now once it's done, let me back and select once again view connection string, and this connection string I need to copy it and I need to paste it in my event generator app config file. That is within the service bus connection string, and this particular entire value I need to just copy and paste with my new Event Hub details, connection string details. So this is the way that you can also create your own data generator in real time through these types of application. And along with that, for this particular demo in vehicle telemetry analysis, I not only process the data through Azure Service Bus Event Hub, because that's only car data has been processing through. What about the details about the weather, the city weather, the car models, these types of details, etc., or vehicle index numbers, etc. So those particular details I have basically in a CSV file, which I have, as you can see, I have already added with my car event generator app itself. Those particular CSV files is getting stored in an Azure blob storage, which would be added as a reference stream as an input of the Stream Analytics. So what I'm doing, I am just restarting the application so that car event generator should start. It is just started, virtual car telemetry analytics. So the generator has been started to process the data. And let me go back to my Stream Analytics. and I've stopped it to show how to add an input. So as you can see, I have two inputs here. One is the blob storage, as in that's the car event data, vehicle index number, and the car models have been stored. And another input, that is where basically the Azure Event Hub input has been getting stored, where basically all the car specific details parameters have been getting stored. So here, as you can see, that the Azure Event Hub input details, like I have to give the service bus namespace, the Event Hub name, the policy name, the policy key, it will take automatically, and event serialization format, that should be chosen as JSON, and encoding, that is UTF-8. And also, for blob storage, which would be added as a reference stream. So there also you need to, since it is a blob storage, it must be coming from some storage account. So you need to provide the storage account settings, the key, the container, and the specific CSV file name. So reference data, since in reference data that's been contains basically the vehicle index number along with the car model details. And also you need to provide the serialization details, like what type of file is that, like CSV and UTF, this connection details you need to provide. For example, if you want to add more inputs to this particular stream analytics job, so you need to click on add input, and you need to select like whether you want to choose for data stream or reference stream. So data stream is basically, the difference between two is, a data stream is a continuous sequence of data of events that is being consumed, like Azure Event Hub, IoT Hub, or blob storage. And reference data would be just like a static data. So for example, any source of ad hoc or auxiliary data that needs to be used for lookups and all. So reference data is basically slow data or static data. So there basically you can choose any blob storage for reference data. So once the input has been processed through, the next job you need to do is basically you need to write a suitable query. Query is again like Stream Analytics SQL query language. So where you need to just, as you can see, it's a pure SQL language. References is that I would be talking later of this webinar, like windowing concept is there, the averaging, like some mathematical analytical functions are there, some specific DMLs are there that we would be talking about, but it's more or less like a pure SQL language interface. So you need to choose up, you can choose up the specific car specific levels that the data has been processed through event hubs. So we can select those of the particular details, and remember that which of the details that you have been writing through your stream analytics query, that particular data only you would be able to fetch in the output itself, because the query would just decide that how you are going to process the data and what sorts of output you want to need. So queries, that's why it is it is actually the main brain of the stream analytics job. So A is a SQL that needs to be processed properly, and you need to give the proper output and input. So output, again, that the output unit that you want to process through. So you have a lot of options to choose an output. Today, Azure Stream Analytics provides this many different platforms to choose an output. Like you can choose either Azure SQL database, so that output of the Stream Analytics jobs again would be stored into the SQL database tables, or you can use Azure Blob Storage. You can again process it to event hubs only. For example, you have millions and trillions of messages and events having processed, and there is a complex data processing or financial data that is being processing through a lot of security channels has been there. So you can even choose output also as an event hub, and then finally push into Document DB or HD Insight. So you can do that even. You can choose Power BI for real-time data visualization. Just I have shown the Power BI dashboard. You can store into the Azure Table Storage for long-time archival or NoSQL data type. You can also again store into the Service Bus queue for continuous message processing, or you can store it as a topic. For example, you want the data should be delivered to the specific consumers based on their level of subscriptions, or you can store it as a JSON like NoSQL storage. So you can store it in Document DB, a very low-cost storage, or Data Lake. It's still preview, but yes, we can store it today in Data Lake as well. So Data Lake Store would be just like a hyperscale repository. So it's the purely big data workload. You can store up the data on top of from Azure Stream Analytics to Data Lake. So today we can store data through Azure Data Lake through USQL query language support from HD Insight for static processing, and then finally the data which has been processed through HD Insight we can store through Data Lake Store. But right now we can store it, the data which has been coming from Azure Stream Analytics, we can process it and store it finally to Azure Data Lake as as well. So whenever you want to capture data from any sizes, huge volume of unstructured data, for example, petabytes or zettabytes of data you want to ingest as a good speed and just in a single space from exploratory or operational analytics purpose, you can use Azure Data Lake Store. So Azure Data Lake typically we use in those of the scenarios where there is petabyte, zettabyte, terabyte, more than terabyte sets of data we have been working so far from HDI or Stream Analytics pipeline to data analytics. So for this demo, I have basically chosen up Power BI that I was actually selected, but you can select also multiple options based on the requirement. So as you can see, this is the output I have given here, Power BI, and the query is already written here. So just selecting the specific details. So the data that has been queried from the input channels, and it has been also joining, that's the data from the data stream, that's from Azure Event Hub, and also the data from blob storage, that's from reference stream, that has been joining so far through the vehicle index number from input.vehicle index number, then is equals to blob storage.vehicle index number, and finally the output data has been processed through Power BI. So that's because you could be able to see the real-time dashboard in Power BI. So what I'm doing right now, I am going to start the job once again. So once you start an existing Stream Analytics job, so you could be able to get to these three options, start output like job start time, custom time, or last stop time. You can start from last stop time. So last stop time means that how much data has been processed till the job was stopped last time. It will start from that period onwards. Custom time means you can specify a specific time period. For example, based on your local time zone, you can select a time period. For example, I can select custom time, and I can give today's date and time. So right now it is, for me, it's 11:32. Let me select 33, and it's AM for me. Clicking on complete so that the job would be restarting once again. And here, as you can see in my lab, the data is being processing. It has been started already to process. And so the Stream Analytics job would be started, and it would start to process the data. And after a few minutes, you could be able to see the dashboard would be again got refreshed because some new data is already processed up. It's going to be processed through Event Hub to Stream Analytics and finally to Power BI. So I would like to talk about next about Azure IoT Suite. So for Azure IoT Suite, you need to go to the dashboard, that AzureIoTSuite.com. And once you are in the Azure IoT Suite, so this portal, first of all, you need to log in, of course. So since I have already logged in with my corp credential, and I have also already created IoT solution in Azure IoT Suite. So what's this actually Azure IoT Suite is doing? What is the utility of that? So to show that, I'm just quickly going back to my slide and would like to show you a very quick customer evidence video. It's just for 2 minutes. That is one of the famous and first Azure IoT Suite case study has been done by Rockwell Automation. And they are just been explaining that how they have gained over the fuels and gas industries using IoT Suite, and they have been Microsoft IoT platform, so that in real time they have been getting real insights of the data through manufacturing and oil and gas industry, and how the data has been processed from millions and trillions of devices in real time. So it will just run for 2 minutes. Okay. Okay, so if it is not, if you can't hear the video, so what you can do, you can visualize the video at this moment, because at the end of the session we are going to share the resources to all of our participants. So I hope that time all could be able to hear. All right, so this is for the predictive maintenance solutions. So let me quickly show. Okay. Fine. So let me quickly show that how IoT Suite works so far. So as I told that about Azure IoT Suite, we could be able to access it through AzureIoTSuite.com, and we can create our own custom solutions. So as a fully integrated provisioning solution. So if you click on that, you could be able to see, first of all, two basic default solution types. So one is being default, that is for predictive maintenances. So just where we could be able to anticipate the maintenance needs and to avoid the unscheduled downtime for connecting the millions and trillions of devices for predictive maintenances. And another solution would be just for the remote monitoring, like these are the two samples actually, the sample solutions you can see in Azure IoT Suite. So where you can connect and monitor the devices to analyze the untapped data and improve the business outcomes. So what I am doing right now is I am showing you my IoT predictive solutions that I have just created. That this solution will basically would identify the potential equipment failure, the IoT devices failures, and how to overcome and optimize the maintenance predictability. So it is a part of predictive maintenance using Azure IoT Suite. So it's also, you can say, like how we can manage the different pipelines of IoT devices. So here, I would like to show you an airline simulation. So I'm just clicking on Start Simulation. And once it has been started, you could be able to see the real-time visualizations and the operations of various sensors over the real time. For example, in a particular airline engine, we know that in a typical Boeing or that there is a small airline, there is two engines would be there. So how the engines have been performing, and over the different sensors, how the data has been pushing through. So for example, engine 1, engine 2, and from the different time interval, how the data has been publishing through. And once the data has been pushing into a good amount, we could be able to see the rest of the analysis as well. That's like the remaining useful life cycles for the airline's engines over the different period of time, and the remaining useful cycles over the engines, the different performance of the engines over the airline, and the different cycles, cycle speed for the engines. So I have started the simulation. So if I have to talk about IoT Suite, that what it actually does. So Azure IoT Suite, as you can see from this dashboard itself. So I just talked about the two popular scenarios with Azure IoT Suite, like remote monitoring and predictive maintenance. Predictive maintenance, this demo you can see using predictive maintenance, like where we can anticipate the maintenance need and avoid this unscheduled downtimes of, for an example, in an airline. By connecting and monitoring the devices, we can check out the various sensors, activities and all. But what is all about the IoT Suite? So for IoT Suite, it helps to connect to quickly and scale with efficiency. So you can use the pre-configured solutions and accelerate the development of your IoT solutions. You can add new devices, or you can add in existing devices. You can use the device SDK. For example, Windows 10 Azure IoT Suite is there. So for multiple platforms, you can work with Linux environment, with Raspberry Pi, connected with a weather sensor or some smart Bluetooth devices, or with your Windows phone or Android phones, or some real-time operating systems, RTOS are also there. So that's all about just like to easily scale from just a few sensors to millions of simultaneously connected devices. That's rely on the global availability of Azure. You can analyze and act on untapped data. So, for example, if you want to collect the previously untapped data from devices and sensors, and you want to build the built-in capabilities to visualize and act on those particular data, so you can set up the real-time analytics by using the SQL-based syntaxes to a highly scalable, highly available, and performance in a resilient way. And you can also integrate some new data science languages like some real-time statistical tool like R, Python, HD Insight, Spark also into the workspaces. And finally, you can enhance the security of your IoT solutions based on the device authentication. And there are today a lot of popular IoT devices are also available, like one of them I already mentioned, Raspberry Pi, then Intel Edison is there, Intel Galileo is there. And in terms of Azure PaaS, you would get the solutions with IoT Hub, Notification Hub, Azure Machine Learning, Stream Analytics, and Power BI. So this is an example of Azure IoT Suite predictive maintenance solution. There is also some more scenarios that if you go ahead, like how to do with the remote monitoring, or how to gain the insights from IoT Suite. So what I would do next, I am switching over. Let me stop this simulation. So as you can see that for this particular IoT predictive solution, this is the entire details of this particular solution that I have built in my IoT Suite. I have a particular solution dashboard. I have an ML workspace. I can see also this particular predictive maintenance template in Cortana Intelligence Gallery. Region, of course, I have where I have just did it. So I will show you also right now to build up the remote monitoring solution in IoT Suite. And you could be also able to modify the particular solutions, or you can get the entire source code also in the GitHub. And finally, if you want to delete this particular solution at any point of time, so you can just click on delete solution. So what I would do first, this is again the dashboard that I have just shown. So I'm clicking on create a new solution, and selecting the remote monitoring one, so that we could be able to connect and monitor the devices just to gain the data insights from the untapped data, and to get the more and more business valuable analytics over there. So selecting those particular solution, it's a template, again I'm saying. So the particular solution if I create, so this particular items would be created, and Azure Active Directory application would be there. One IoT Hub would be used, S2, that's the standard tier. Pricing would be based on the standard tier. One document DB account would be did, S1. 2 event hubs would be using, that's for data streaming purposes, basic throughput unit. 1 storage account, standard geo-redundant would be there. 3 stream analytics jobs would be needed, 1 streaming unit per job would be there. And 1 app service, web app or websites would be there. So what I'm doing, I am just creating the solution very quickly, just giving a name. And selecting the subscription, selecting the region, Southeast Asia. I'm just going to create the solution. And click on details to see the status of the jobs provisioning. So what I was doing manually, just creating the event hub, processing data through data generator, pushing it through event hub as an input, then writing the stream analytics query, and then publishing out through the output through DocumentDB or Power BI. This IoT Suite is just doing everything for me. Now, not only these two particular templates like Predictive Maintenance and IoT Suite Remoting Connecting Devices Analytics, I can use any particular fully integrated solutions also, and I can add it to this particular IoT Suite solution. So in Azure Stream Analytics, once you create the job, you could be able to see a lot of other options are there. So as I was mentioning, like there is a separate monitor tab is there. So in the monitor tab, you could be basically able to see the input events, output events, runtime errors, or the service unit utilization, fail request tracing, fail function request, all those specific details that could be able to see over there. So by default, there will be some specific parameters to be selected like data conversion errors, out of order events, input event bytes, the late input bytes, etc. But you can also select it for yourself. So maximum 7 parameters you can select for yourself. So one of them you can uncheck and you can select the rest of them, whichever are based on the requirement. And you can also select this particular monitor. You can monitor the specific job over the certain time period, like from 1 hour to max 7 days. You can monitor the jobs over there. Like from 1 hour to 12 hour to 24 hours, 24 hours to 7 days, you can monitor the jobs. And not only just a relative graph, but you can also view the absolute graphs as well over the time period. This monitoring dashboard just gives us an insight. For example, I have provisioned my Azure Stream Analytics job. I have connected the proper input, Stream Analytics, Blob Storage, or IoT Hub. I have written my ESS SQL query. Now again, I have given my output that has also been connected through the real-time Power BI dashboard. But again, I am not able to get the proper output in time. So this monitoring dashboard would just be helpful for me in that time to understand that if there is an interconnected data mismatch issues or input data overflow issues, because that is a very common errors comes up with Stream Analytics. So also, in Stream Analytics, you could be able to scale up the job, as I was talking in beginning of the webinar, how we can scale streaming a unit pool over the Stream Analytics job. So a Stream Analytics job, it can be scaled through the specific streaming unit, so which could be defined that how much the amount of processing of a job receives. For example, today I am doing some Twitter sentiment analytics over the Rio Olympics data. So Rio Olympics data, for example, I'm collecting over the real time. So it has been started the event, and so we have been started to get the millions and trillions of tweets per second and per minute. So to process those kind of Twitter streaming, which I'll be also showing in my demo today, so how I can increase my streaming units. So by default, based on your subscription, my job is running right now. So for example, any of the particular streaming units, you can configure it maximums of 20, but more than that also you can add the streaming unit. So for additional streaming unit, if you want, you can send an email or you can contact Microsoft support, so that based on the subscription level, you can add the streaming units. But again, it will be based on the data, that input data per second, per minute, per GB, per TB that would be processing, because the pricing would be also getting changed based on the streaming units here. And you can also configure it over the time. So for example, in Configure tab in Stream Analytics job, you could be able to see the late arrival tolerance, out of order tolerance events. You can also set the specific locale. For example, your data has been processed in a specific language, for example, in Spanish or in German other than NUS. So you can also set up the specific locale of the language settings for the internationalization preferences, because IoT Suite also works not only for regional account, it works also for international accounts itself. And you can also select the regional monitoring storage account. For example, when you are provisioning an Azure Stream Analytics job, by default, a storage account is already get provisioned, because storage account is just like a storehouse for Azure Stream Analytics job. So all kinds of data, events, logs, by default, it's going to be stored in that particular storage account. So, and the storage account, that particular storage account, that needs to be GRS. It's a global redundant storage account, so that the copy of that entire data of that particular Stream Analytics, the ASA job, would be getting stored into the as a replica into the another another data center of the same region. And today, just few months back, Azure Stream Analytics job that can be also connected with Azure Machine Learning, AML. So it is still now in preview. So I would be talking in my Twitter Analytics demo. I'd be talking more about ASA AML connection integration scenario. But this is today, right now, you can have an approach with Azure Stream Analytics. IoT Hub, you can connect your IoT Hub with Azure Stream Analytics job, and you can publish the events from millions and trillions of devices, from device to cloud or cloud to device, and then from Event Hub to Stream Analytics. You can process it. But IoT Hub connected with Stream Analytics is still now in preview, and you can check out in the new portal itself. All right, so I'm getting back to my slide once again. I'll be coming back once again once my IoT Suite remote monitoring solution has been finished the provisioning. Then I'll be coming back to the demo once again. So the scenario that we have talked about, we have already mentioned about complex data processing and the stream processing in real-time stream processing. So let's coming out some sorts of architecture discussion. What are the various layers of reference architectures that's being connected through these types of end-to-end real-time streaming? So from sensor to live dashboards and to alerts in just to get 10 minutes. So it is very important that from an IoT devices, while the data has been processed through the device, it has been pushing into some streaming units, process it, and finally pushed into ASA, Azure Stream Analytics, moving it and processed it through SQL query and published it to some real-time dashboard. And we have been getting alerts just in few time interval. The data has been processed, and this is the nature of data. This is the average temperature. This is the average humidity. This is the weather prediction for next 5 days. So these are the kinds of scenario, and so some sorts of reference architecture is being needed while we have been working in real time for this kind of an enterprise projects. So as you can see in this deck, I have been just showing up an end-to-end scenario while being working with real-time data analytics and some sorts of architecture designing. So the first layer, as you can see, that it is a source of event producer, or we can call it as a presentation or consumption layer. So in the end-to-end architecture level, when we have to design the solution architecture, so we have to start from event producer or consumption level to the data source or data visualization level itself. So in consumption level, you could be able to do basically the things like rich interactive visualizations, like where the data would be processed and application integrations for process automations, these things that needs to be done. Then once the data has been collected from those devices, like various sensors that has been connected through IoT Hub or Event Hub, or they have been pushed through the various gateways or through Web API, Azure Web Apps, or any kinds of IoT Hubs devices. So that is with the collection layer. Now from the collection layer, the data has been pushed into the ingestion layer, or we can say as a broker. So the data has been finally pushed it either through Event Hub, Service Bus, Notification Hub, any Service Bus, Event Hub, or Notification Hub, or IoT Hub. And finally, once the data has been ingested into the ingester from on-prem device, IoT device, to the cloud, Event Hub, Notification Hub, or IoT Hub, so then the job comes out that how to get the analytics part. So analytics parts means again comes up the transformation stage. So here is actually the beauty of the job, that how you want to transform your data. Because every sensor or every device is just sending you some basic sets of information. So for example, a weather sensor data would be providing you the information like the device, the humidity, the temperature level, maximum temperature, minimum temperature, then weather wind circulation level, barometer pressure, like that. But how I am going to get the insight from those of the specific details, like what is the top 5 temperature prediction for last 5 days, or what was the next 5 days weather prediction. So how I'm going to get the insight of the data, it depends on me, that how I'm going to transform the data through Stream Analytics. So that again depends on the nature of the engine that you are choosing so far, like the types of inputs, whether data stream or reference stream. the types of queries that you have been writing so far, the SQL query, how you have been consolidating and stored the raw events into the files for historical analysis, how you have been storing, aggregating the filtered events into the storage, how you have been consuming the reference data to compare the current and historical data, how you have been aggregating, filtering, or pushing out the joining over the incoming event streams, or the kinds of predictive analytics that is based on the models, just leveraging the incoming events and output events. So data integration is also a very important part. So with the stream analytics, you have to identify the nature of the data inputs that you have been giving so far. So whether you need to choose the event hub, whether you need to choose the IoT hub, or whether it would be a static data, you just need to join with the event hub data, IoT hub data with blob storage data. So that you have to choose as per as your requirement, and you need to design your stream analytics job so far. And finally, once the job has been written and it has been pushed into and published through, the next part of the designing is basically that how we are going to store the data. So data storage is also, it's an equally important considerations that why we need to give for data integration part. Because long-term storage means once the data has been processed through stream analytics, how we are going to get the valuable insights from those data. Because we are not working with undiscarded or unuseful data. We have been really getting insights now with the actual data that we have been looking for. The next 5 days predictive analytics of the weather data. So those kind of data, while we have been thinking for long-term storage, we have to think of some kind of fantasy, some kinds of visualization, some cool visualization technique that also we can choose. Of course, we can take help of Power BI, or we can take off service bus event hubs once again for complex event processing, for example, if we are doing, or we can take off Azure, take help of Azure web apps. So we can build up an ASP.NET website with having some cool integrations with data grid and good charts and visualizations, and we can move into as an Azure web app and app services. We can integrate with Azure mobile backend and all. So this is basically the data integrations and persisting the reference data. It's an equal important. And the architecture, the solution architecture, as you can see in this particular diagram, so it's basically is a real-time event processing reference architecture, which is dependent on the number of different Azure PaaS capability, platform as a services capability. And it helps to support the end-to-end analytical scenarios. And this is the diagram that's and the subsequent sections that, as I have described so far, it defines the various stages of the data flow lifecycle within the architecture, as well as the various components that's required to support each of the stages and how it needs to be interacted with the various components. So also, it is unlikely to mention like all of the components that is relevant for the end-to-end real-time data streaming implementation. So we can use it in any kind of a scenario. Actually, whether today you are doing web log click stream analytics in real time, or you have been thinking to go ahead with fraud detection analysis, or you have been thinking with connected car telemetry analysis. So all such kind of scenarios you can apply this particular role so far. Right. So I'm going to another demo. It's one of the funny demo with howworld.net. So with howworld.net, they are also having a real-time Power BI dashboard, which is specific to Microsoft internal usage purpose. So I'm just showing you how this app works. So this is basically a simple, the website actually. It is being developed by Microsoft, and they are also, till now, they have been working so far to make this app is more and more brilliant. To tell in the beginning that howworld.net it's a robot. So it's nothing like something that someone is being working in backend and just giving me the results. Nothing like that. In backend, it's working Azure machine learning solution. So a pure ML solution is being working so far, which is giving me the prediction results. And also, when I am just being uploading some kinds of photos, any people photos, so some kinds of API has been working, which is detecting the people's ages. So this particular website has been published last year as people use it, but it's, again, I'm telling it's just for fun. But yes, it's nothing like a non-technical scenario. It's a pure technical architecture is being there in backend of that. So the data that I have been giving in real time in this website, it is being storing and pushing into Azure Event Hub, Service Bus Event Hub, and it is being published through Azure Stream Analytics. And Azure Stream Analytics has been integrated with AML, Azure Machine Learning. Azure Machine Learning, it is being working with Face API, and from the Face API itself, it is being correlating and defining some sorts of algorithms that is being defining the particular age of the people, the condition, the face condition of the people, that whether he or she is happy or sad or just smiling with joy, those kinds of things. And finally, the results have been given to me in the dashboard itself. So again, it's an end-to-end scenario. So what I'm doing, I am just using an arbitrary photo of some kids. So 5 kids are there, and very soon I'll be able to see their ages. So it's correct. So one of the boys age of 5, one lady, one girl is age of 8, she is 6, this girl is age of 13. So as I can see that how it is being in real time, it's helpful and it's helping me to detect the age of the people. So it is just like an example of real-time data streaming with machine learning capability, Azure machine learning capability. Now this website is also getting improved a lot because as you can see that we have not did quite get it right. We are still improving the features. So you can also add, you can check out the code in the GitHub of this particular web app, or you can also send your own ideas and views or feedbacks for this particular web app. But yes, machine learning and the data streaming team, they have been working a lot to make this app is more being powerful. And very soon they are going to integrate with Cortana Intelligence Gallery. They will be publishing this kind of, again, an app that would be detecting the emotion of the people as well, whom faces you have just uploaded as a photo into the website. So whether they are happy, whether they are sad, or whether some of them are weeping, so that's all the information that would be available over there. So this is an example of Azure Stream Analytics with Azure AML integration. That's a real-time sample. Now I'm going back to my Azure IoT Suite and just would like to see that what's the status. Yes, my job is ready right now. So I am just selecting, I'm launching my IoT Suite remoting application. So just to see the monitoring the events and conditions from the devices. So launching this app. Let me sign in. Is there any questions, any queries so far? You guys can let me know. All right. So I can see a remote monitoring solution, real time. So nothing, a big data problem with static or scale data. Everything is being working in real time. What I'm doing, I'm just little zooming this because my screen is not much bigger. Okay. All right. So as you can see, let me do it a Bing's bird's eye view. So this is, you can see the telemetry history over the apps so far, IoT devices so far, and this is actually the dashboard that's in the Bing's bird's eye view. So how in the different cities, the vehicle telemetry that has been done so far. So the telemetry history, the temperature and the humidity level of the devices. Actually, it is being working on the weather sensor. So it's being just predicting over the period of time what was the temperature level and the humidity level. So it is being taking up the current date and time of my devices, and also it is predicting the maximums of device humidity, the minimums of device humidity, and averages of device humidity. Here in the alarms history, you can also see that for the device's specific device ID, what was the rule input, output, and the values, and according to the local time, how the value is being getting changed so far. You can see here basically the device's name. I'm clicked on the devices, so you can see the 4 sample Windows weather sensor devices has been running so far with Azure IoT Hub, and it is basically targeted for manufacturing industry. So for imaginary company Contoso, the specific devices has been running with a specific model number, serial number, firmware, and the platform. You can see the rules. So in the rules tab, you could be able to see the various rules that which has been enabled, that how the devices will be sending the data. So one specific IoT device will be sending the temperature data. One specific IoT device will be sending the humidity data. And what would be the operator, what would be the threshold level, what particular time those devices would be sending the data. That's all the information would be kept here in the rules tab. If you click on the actions, so in the actions, you could be able to see the humidity level. You can raise an alarm. If the humidity level goes high, you can also specifically, you can send some specific messages for a specific time period over some temperature has got increases and all. So this is just like I have just shown in my slide, like how to send once the data has been processed through real-time through Stream Analytics, and I'm just getting the information through my real-time Power BI dashboard, how at the same time I could be getting the alerts. And in the settings tab, if you click, you can be able to see the Jasper API. Jasper is basically a Jasper Central Control Authentication. It's the Java-based API that you can use as a Jasper API integration as a cellular device connections. Or you can also add your own IoT devices. Just like as I mentioned, there are millions of IoT devices. I mean, for Azure IoT also, there are thousands of devices are there. Intel Galileo is there. Intel Edison is being there. Raspberry Pi 2, 3 is being there. Azure IoT Suite is there. And a lot of third-party devices are being also there. So you can connect your own IoT devices, or you can just add your own devices, just clicking on add, and you can simulate the devices, or you can also connect a physical hardware devices, just like a weather sensors or anything. You can add it over there. So here I'm just going back once again to the sensor, and if I want to get for a specific areas, for example, in Bellevue, I am just selecting the sample device, my IoT device, that is 214. So I could be able to see the real time, the temperature and humidity graph over the time for the specific sensors. Now let me go back to again to the another device, selecting another device, that is sensor device 4, and I can see this particular temperature and humidity level. I can also select from the drop down itself. 2, this is 3. So 3 is just like this, the humidity level. This comes to 1. This is the humidity level. So this particular demo has been made so far in 4 different areas. Let me once again get my crop credentials. In 4 different areas. In Seattle, Redmond, and Bellevue, and Summerish. So. So this is how, with Azure IoT Suite, the remote monitoring solution that has been developed. So I have just did the plug and play, but you can start with this template and the template application, that how to work with Azure IoT Suite, and with the help of Azure IoT Suite, with the remote monitoring solution, connecting your IoT devices through cloud and process the data through Azure Active Directory, through IoT Hub, Event Hub, Notification Hubs API, and process the data through Azure Stream Analytics, publish into Power BI and Azure Web App Solution. So here the data has been processed again through not only Power BI but also with Azure Web Apps. So it is just a kind of an Azure Web App. So as you can see, the website has been hosted into Azure Suite remoting.azurewebsites.net. And if you go back to your portal, once again, you could be able to see that all these particular components that has been provisioned, and I have just given my own subscription to launch these particular jobs, that all have been launched in my portal itself. So, and also with this particular existing solution, you can also add your own devices, own custom IoT devices as well. All right. So let me go coming to my other demos. So as I was talking about howworld.net, the PPT presentation. So let me talk about now the advantages of using Azure Stream Analytics and what is the advantages of using the cloud for real-time data streaming. As I was talking about the various layers in the data sources, like data integration layer, Azure Event Hub. So data integration layer, as I was talking about, like where the data has been pushing directly into Azure Event Hub, where the data is coming from various devices, applications like Azure websites or sensors or Bluetooth devices or phones or connected telemetry devices or third-party data streams, and the data has been pushed into event hubs. So both event hubs and Azure Blob Storage, they are foundational storage components for Azure Stream Analytics that often support the additional solution scenarios outside the real-time analytics. So basically, while we have been talking about the IoT data analytics, so mainly as such that they create a natural data integration point for additional workloads such as archival storage or for batch analytics or for supporting self-service business intelligence. So in the cloud, we can scale in such cases both of the types of application. We can scale as much as, and we can check the pricing tier as per as required. So for example, for a relative small set of real-time data streaming, I can select max 3 units, and I can process this particular numbers of messages. And while per minute or per day, for example, 9 gigs of data could be processed over the time. And the pricing tier would be, of course, would be that as much as we have been using so far. And based whenever I'm thinking for a real-time data streaming, for example, from social media analytics, like a real-time event whenever it's been happening, for example, like Olympics data, which is been happening right now. So, of course, I can increase my scaling unit. I can scale up my job as such a way, and I can also check up my pricing tier based on the requirement. So pricing, of course, Stream Analytics is priced as based on the 2 variables. First of all, the volumes of data that has been processed so far, and second of all, the streaming units that's required to process the data stream. So volume of data, you have to be paid per unit. It's a low cost, say 0.001 cents per gigs. Or if you talk about the streaming units, like in terms of CPU, memory, and throughputs, the usage, so that would be also costing about 0.31 cents per hour. So it is being maximum, the streaming unit would be just like a complete capacity of maximum of 1 MB per second. So this is an example pricing, as you can see, that if you process a daily stream analytics job, so what would be the cost for 1 MB per second for average pricing? It's comes about $24.60 per month. Next, I would be talking about a little about Stream Analytics query languages. So SAQL, which is being in short, it's called about. So there are various kind of, I already mentioned about that we have to write the various sorts of Stream Analytics query languages. Now SAQL in the language perspective, it has various sorts of functions, date and time function, aggregate function. It's all for pure analytics approach. So we have the DML, that's the data manipulation languages. So it's a plain like SQL. So of course we must have select from, where, clause, group by clause, having clauses, union, cast, order by, etc. But apart from that, for the proper scaling support, in Stream Analytics SQL, we have partition by clauses. We have over clauses. For date and time functions, for example, if you are working with real-time data that has a date, time separately as a schema, so you can add a specific date time functions like date name, date part, month, year, etc., date difference, etc. You can add specific temporal functions like collect, top, lag is first. You can add some specific aggregate functions. So just like sum, count, average, because all over the most ASA, it's a cloud services that enables the real-time processing over the streams that the data has been flowing from devices, sensors, websites, and other live streams. So the stream processing logic in ASA is just being expressed all over like a SQL-like query languages with some added extensions such as windowing for performing temporal calculation. Okay. So as Azure Stream Analytics is purely it's a temporal system, so every event that being flows through, it must have a timestamp. So timestamp, as you know, is just like equivalent to date. So with the timestamp, you can specify like per the time unit, how many cars have been processed through in the toll highway, or how many events that has been processed through the sensor devices. So for that region, in a specific Azure Stream Analytics region, so in the region specific, we can also define a specific concept, specifically in IoT demonstrations, that would be defining like windowing extension. So as you can see, there are 3 types of window has been available in whenever we are writing the Azure Stream Analytics query. So one of them is being called as tumbling window, another one is called as hopping window, and third one is called the sliding window. Now, what is the differences between these 3 types of windows and how it is working so far? So, if I go through here, for example, how the events are being processed. So, as I mentioned, like every event in Azure Stream Analytics that flows through the system, that it has a timestamp, and it helps to projecting the timestamp as a payload. So, for example, you have been collecting the data from real-time in from Twitter Stream. So, you can just mention about select star from Twitter Stream, or you can just mention also the specific timestamp as a time text from Twitter Stream. So, in windowing concept, in Azure Stream Analytics. So windowing is a core requirement for stream processing applications to perform the set-based operations like counts or aggregations over events that arrive within the specific period of time. So ASS typically supports 3 types of windowing: tumbling, hopping, and sliding. So windows, of course, they are always being the fixed length, and output event of the specific timestamp would be always must be the end of the window. Now, tumbling window, it actually defines the repeating non-overlapping window of time. So, for example, I want to calculate the count of sensor readings per devices for every 10 seconds. So, of course, I have to take help of tumbling window. So what sorts of query I can write then if I want to calculate the count of sensor readings per devices for every 10 seconds. So I can simply write like I can select the sensor ID, select sensor ID, count of star as count from sensor readings, timestamp by time, of course over the time per particular time period I want to calculate, group by sensor ID, then tumbling window I can select for second, 10. So something I could like write like this way. Just taking a simple notepad, and I can write select sensor ID count of star from count of star as count from sensor readings. Timestamp you can write in caps as well. Timestamp by time. Group by clause you have to use. Group by. Of course, it should be sensor ID. And then I can write the tumbling window. That's tumbling window second 10. So, what I want to do with this query, basically this query will calculate the count of the sensor readings, the meters, per every devices for every 10 seconds. So definitely I should go ahead with then this time with a tumbling window. The second query that works is basically that so far is we call as sliding window. or hopping. Before that, we would be talking about hopping window. So hopping window is being basically it helps to move forward in time by a fixed period that they can overlap with one another. So every 5 seconds, for example, I want to give the count of tweets, and I need to also calculate the average sentiment score over the last 10 seconds. So for this particular scenarios, I can use the hopping window. So for every 10 seconds interval, the hopping window will be just a hop for a 5 seconds interval. So this is an example of hopping window. A window query. So for example, every 5 seconds to calculate the count of sensor readings and average temperature over the last 10 seconds. So I need to write basically the same query. I need to also add an average temperature from sensor readings, and also I can particularly group by them with sensor ID and hopping window with second 10 to 5. So that means every 5 seconds interval, 5 times 5 seconds hopping will be takes place. So hopping window also has its own essence. So it will just to help you to move forward over the period of time by a fixed period. So just in 10 seconds, in every 10 seconds, just in 5 seconds hop interval, the windowing will be takes place, and I could be able to get the readings so far. The third type of window we call as a sliding window in Stream Analytics. So with a sliding window, the system is typically it's being asked to logically consider all the possible windows of a given length and the output events for the cases when the content of the window actually gets changed. So that is when, suppose for example, an event entered an existing window. So in that cases, we can use a sliding window. So for example, I want to generate an output event if the temperature is above 75 for a total of 5 seconds interval. So what I can do, I can use a sliding window and I can specify the interval of 5, total of 5 seconds. Similarly, this example in the deck, you can see sliding window of second of 10. So for example, if for social media analytics, I want to count the number of tweets for all the topics which has been tweeted more than 10 times in last 10 seconds, so that I can give the interval of sliding window with second of 10. Not only that, we can also join the multiple streams with Azure Stream Analytics. One of the joining conditions I have shown you for the vehicle telemetry analysis. Apart from that, we can use the AML functions, Azure machine learning functions, which is you can integrate. It's in private preview, but you can enable you to call the ML models with streaming data units, and also you can join the reference data as well. So for example, list of all users and topics on which the sentiment analysis has been done. So for example, there is a Twitter sentiment analysis has been done on the specific keywords like Xbox, ALS, Ebola, etc. So in that cases, if I want to join the two different data streams, so I can join, for example, reference data, which is a static data which is being stored in the blob storage. So it is often used for performing the lookups and correlations. So that data also we can join with event hub data. Or if we have multiple outputs we want to support, like ASA actually supports the multiple computations and output targets to the single job. So you can use a simple into keywords and you can apply it to the output target. So for sensor readings, you can add an into keyword and process into the specific output parameter, the output layer. So as you can see, that multiple units that we could be able to join. And reference data, as I mentioned, like Stream Analytics helps to seamless correlations of event streams. So, of course, the same programming experiences. Any SQL developer can write a simple ASA query language, Stream Analytics query languages, and you can join also the multiple streams from the various reference data joining that could be possible. We can join data streams inputs with reference data stream inputs. So from blob storage data, we can join with the event hub data, or we can also connect with IoT streams data, IoT hub input streams data. So all that could be connected and processed through the Stream Analytics. In terms of scaling, Azure Stream Analytics, it helps to scale with proper complex partitions. So as I mentioned, like while I have been provisioning the Azure Event Hub, so I need to mention the partitioning unit. So as I mentioned that you can give it 7, 16 or max 32. So why this partitioning is important? So based on the partitions that a specific partition ID has been assigned to the Event Hub, and those particular partition ID, the query wise, the data would be get divided and processed into the streaming scaling unit in ASA. And finally, the results is being getting processed from the ASA like this. So Azure Event Hub and ASA is being typically based on the conditions of pure partitioning. It's a part of patterns and practices. But yes, with a proper partition, if you apply in ASA SQL a partition by clause, so the particular partition ID will help to process your data much more faster. So there are some optimizing process as well to optimize your ASA SQL query. So you have to select first of all a proper window, tumbling window, hopping window, or sliding window, and you need to select a proper partition unit as well. Like for the parallel executions, it's a part of TPL, task parallelization unit, and also for scaling, for the proper scaling out. So as much as jobs would be processed through the for the millions of events processing. Next, I will be going through the code. But before that, I would like to go you through a specific solution architecture diagram for this particular apps. So I'd be showing you basically a solution architecture. This is a diagram. Next, I'll be showing you the demo. The solution architecture diagrams of real-time Twitter streaming analytics of Rio Olympics, hashtag Rio Olympics 2016. So first of all, in this life cycle, as you can see, the data which has been collected from Twitter based on the specific keywords like hash Rio 2016, hashtag Rio Olympics 2016. And once the data, once the real-time tweets have been collected, it has been stored into OneDrive storage. So as a CSV file, the tweets have been getting stored into OneDrive. Now finally, from the data from OneDrive, it has been pushed into Azure Service Bus Event Hub. And from the Event Hub, that particular jobs based on the partitioning and scaling, the data has been pushed into Azure Service Bus, Azure streaming units, that is in ASA, Azure Stream Analytics from the Event Hubs. And from the Stream Analytics, I have been also connected as a functions. I have been added a AML functions like Azure Machine Learning. So the Stream Analytics have been subscribing to Predictive Twitter Sentiment Model that is being available in Cortana Intelligence Gallery. I will be showing you. And from the Machine Learning algorithm, that's been deciding that the particular tweet is positive, negative, and neutral. So all the tweets that based on the value of 0.5, that would be positive. All the tweets that's within 0.5 is neutral, and any tweets that's below 0.5 level or the score, that would be treated as a negative tweet. So this machine learning, that would be just like an added extension layer on top of Azure Stream Analytics, Azure ML Web Services, that they're being added as an URL and key with the ASA input as a function. And finally, the output from the machine learning has been taken into the Azure Blob Storage as an output with ASA ML integration job. And finally, from the Blob Storage, the data has been published through Power BI. So what I will do next, I will showing you the demo. So let me push it into my lab and let me show you the code by which I am collecting the real-time tweets from the Olympics data. So as you can see in the Eclipse, I have just written a simple Java code by which I am collecting the real-time tweets from those specific keywords like hashtag Rio 2016 and hashtag Rio Olympics 2016. And this is the tweets, as you can see, very fast. It's been coming, for example, thousands to millions at per minute it has been collected so far. And the data, it has been pushed into, it's being stored into the Azure OneDrive storage, Microsoft OneDrive storage. So here I have my tweets that being stored. This is the tweets in CSV format. These are the tweets. Tweet text. And I have here an application that is passing the data from OneDrive storage into Azure Event Hub. So I have given here my Event Hub credential, and this is the program. That helps me to push the data. So it is pushing into Azure Event Hub, and here I have my Azure Event Hub, my Azure Stream Analytics job that's been running so far. So you can see here the query that I have written, topic, count, sentiment, score, and all. And also I have added some sorts of functions here. So functions also we could be added so far. I have also here the input that the Stream Analytics, the Azure Event Hub input, that is the Twitter input, that from the Azure, from the OneDrive to Event Hub, it is being processed. So that has been added as an input. And in the output, I have given basically SQL database, or you can also add a specific blob storage as well. So if you go here, you could be able to see I've also added output as a blob storage. I have added a specific result set for the scored levels. I have a function. This is my sentiment function. URL, that is US Central, AzureML.net. So I have also a specific Azure Machine Learning Studio that I have taken so far. And from there, I have just added this parameters. And in the output, in the blob storage, I have this output that is being stored. So again, going back to the lab, and here I have Azure Storage Explorer, where you could be able to see the outputs of the sentiment analysis. So what I'm doing, I'm downloading this blob file, and I'm just saving it so that I can show you. Let's go back to the downloads, and this is my CSV file. That contains actually the output from the blob storage. Clicking on edit, and you can see here the outputs of the tweet outputs. So this is the text of the tweets, and again I have the scores, sentiments of the tweets. So first of the few tweets you can see Magistral, Dennis Chenat, Olympics, Serena Williams beat for second consecutive Olympic singles gold medal, wins with loss. So it goes for positive since Serena Williams is there, 0.75. Rest of the tweets, more than 0.5, that is all the positive tweets. Some of the tweets are within 0.52, these are the neutral tweets. And some of the tweets are definitely negative tweets. Some people lost, some athletes lost the match, so it's a negative tweets. Again, we have got a very positive tweets for Deepa Karmakar, has wanted to a physio checkup. We are expecting to be in the final today or in the Sunday. So this is the outputs of Twitter Sentiment Analytics for Rio Olympics 2016. I have also a simultaneous Power BI dashboard with me, so you can see the outputs over the sentiments over the time that has been built with Azure Stream Analytics and Azure Machine Learning Predictive Model. So here you can see some of the top positive tweets. Gold in 200-meter butterfly, Rio 2016 extra awesome, Rio 2016 denied permissions after qualifications, billion cheers to him, takes him to bring glory to India. Lot of tweets from Michael Phelps, USA Men Championship. So these are all positive sentiments. And here, those are the positive tweets that we can see over. And also along with that, we can see the scores as well, the total score. So you can see some of the most positive tweets here that scored more than 33.64 is that Rio 2016 extra awesome. Then some positive tweets like Rio 2016, congrats Pandela Jun for Nail Historic Silver Medal Championship. Some of the tweets like gold in the 200-meter butterfly. Some of the positive tweets with Rio 2016 with Michael Phelps, Serena Williams. That's all are going to be the positive sentiments. So along with that, so this example, this demo is basically showing that how I have done the real-time Twitter sentiment analytics using Azure Event Hub, Service Bus Event Hubs to Stream Analytics, connected with Azure Machine Learning, that for predictive maintenance, for predictive modeling and analytics, that's to count the sentiment scores of the real-time tweets, and finally pushing into Power BI. Another demo I would like to show you is basically, this is again on Twitter Sentiments Analytics, but the keywords are different, of course. Keywords here in this particular demo, I have taken from the specific keywords like Cortana, hashtag Azure, hashtag Big Data, IoT, and MSFT. And the tweets here that has been collected with usernames, their profile locations, their country, that from where the users are coming from, and the countries. So what I've done, so this code is basically just collecting the tweets and saving on the local drive, that's in OneDrive storage. So you can see here goes my tweets. These are the specific tweets there. I have also an application that is being running so far. Let me run it once again. And it is being pushing out the tweets. And I have in my Power BI, just give me some time. So we'll be finishing before time itself. Since we have started 10:45 a.m. today, we'll be finishing within 12:40 or 42 of the time. Yeah. Let me switch back. Let me open the Power BI. We can also take up the question. So please let me know if any of you have any queries, any questions so far. So this dashboard would be actually showing the real-time Twitter analysis. So I have already shown the pipeline and the tweets that has been coming from. So here you can see the visualization of the Twitter streaming. So the tweets from this visuals, you can see that who's of the particular Twitter user having tweeted most on the specific topics like hashtag IoT, hashtag big data, hashtag Azure, MSFT, and tweeted most. So these are the top tweeters with their specific tweet IDs. And here you can see here the top countries where the tweets are coming from US, Canada, from Germany, from Sudan, from South Africa, again from Mexico, from India, from Finland. These are the specific countries where the tweets are mostly coming from. And again from other countries like Chile, Brooklyn, Bangalore, Alabama, EMEA, then Netherlands, Lisbon, almost the tweets profile locations who have been tweeted most on the specific keywords, hashtag IoT, hashtag big data, hashtag Azure. These are the specific tweet contents that has been people are tweeted most on smart cities, IoTs, open datas. And also I have a specific Power BI dashboard as well. Power BI desktop dashboard, which will also show you the top tweets counts based on the topics. So for example, this particular aquarium fish, as you can see, the size of the fish actually denotes the top numbers of tweets. So for example, till now for IoT itself over today, more than 26,000 tweets has been done so far. Similarly, the topic on hashtag big data, around 24,304 tweets have been done so far, even today only. On Azure today, there are 9,112 tweets have been done so far. If you want to select for the specific topic wise, you can select the total numbers of tweets and the percentage over the tweets. If you want to select on MSFT, how many tweets have been done is 3,308 tweets have been done so far. So this is an example of real-time Twitter streaming analytics with the Azure Stream Analytics, Event Hubs, Power BI, and of course the real-time data streaming. So this is an end-to-end scenario of IoT analytics, gaining real-time insights with Azure Stream Analytics and Internet of Things. So we can take up the questions. We are almost at the end of the session. So as you can see, there are some kinds of resources that has been already coupled up here. So you can follow up the ASA team blog. You can see up enter documentation on Azure Stream Analytics over MSDN blogs. You can also sign up for private preview of ASA ML. You can follow up this link and you can sign up for the preview. Once your application got approved by the internal team, so you would be responded back. You can follow up the Stream Analytics team over Twitter. You can check out the forum, or you can directly send an email to the ASA team for any sorts of help or technical queries. Or of course, anytime you can get back to us as well for any questions, concerns. So I hope Devik already shared our contact details. So you can send me an email directly to annbasa@microsoft.com. So for any questions, queries on IoT, Azure, Stream Analytics, Event Hubs, Azure Machine Learning, any sorts of questions, queries on big data or real-time queries. So folks, that's all for today from my side. Please let me know if there is any questions, concerns or queries. And also, if you guys can share your contact details, your official contact details, your email IDs, that would be very much helpful for us so that we can send you the resources after the end of the sessions or within next few days itself. All right. So I have just shared a poll with all of you. Please rate your feedback over there. Okay, there is a question from Swati. How we can use Azure Machine Learning in other scenarios? So Swati, if I can understand your question properly, other scenarios means apart from using Azure Stream Analytics, if it is. So yes, you can use Azure Machine Learning independently as well. It's not like mandatory that you have to use Azure Stream Analytics. It depends on the kind of the requirement that you have been using so far. So whether you're having taking like a real-time data streaming, for example, just like Twitter data streaming I have mentioned so far. So of course, where the data is being coming in real time and pushing into Event Hub and processing through Stream Analytics, of course you can add Azure Machine Learning. But apart from that, Azure Machine Learning could be used in the scenario just like I have mentioned about Howell.net. So there you can use it for real-time face recognition, speech recognition, speech-to-text recognition purposes, or you can use for real-time fraud detection. You can use for anomaly detection, so clickstream detection. So yes, you can use it independently. You just need to provision the Azure ML Studio, which is free of cost. You can freely sign in over there. But yes, based on if you want to have a team set up over there, and for enterprise setup, you need to go ahead and with your proper Azure subscription. But Azure ML, if you want to play with that first, you can do it on free of cost.